Your robot works flawlessly, picks up the cup every time. Then you move the camera 2 inches, just 2 inches, and suddenly the robot flails. It knocks the cup over, it grabs empty air, it outputs pure garbage. Nothing about the robot changed. Nothing about the task changed, just the angle, and the entire brain broke. Every robot AI on Earth has this exact problem. It learns the camera, the angles, the mounting, bakes it all into its weights, and the second you change the setup, it is lost. A new paper has a fix so simple it is almost funny. Before the task, just let the robot wiggle. Here is why it breaks. Today's robot brains, the VLA models, learn one thing: action, given what they see and what you say. But the camera angle, the robot's shape, how it is mounted, all of that is frozen into the training data and absorbed into the weights. Deploy on a different camera, and the model has zero mechanism to figure out the new mapping. It just spits out garbage actions. The standard fix is fine-tuning, a brand new training run for every new setup. That is expensive. It needs a human in the loop, and it completely kills the dream of one generalist robot that works anywhere. The paper reframes this as a system identification problem. The robot brain needs to know the setup at test time. Instead of fine-tuning, why not just figure it out from a few seconds of moving around? Think about grabbing a video game controller you have never used. You do not immediately attempt the boss fight. You wiggle the sticks. You watch what happens. Within seconds, you have built a mental model of how inputs map to outputs. Now you can play. That is the entire idea. Let the robot wiggle, watch, learn the controls, then do the job. Here is how it works. Before the task, the robot does about 20 random probing movements. Takes 5 or 6 seconds. You record short clips of those movements. Each clip is a triplet: start image, the action, the end image. Then you feed those clips to the model as context, right before the actual task. A single photo cannot tell you the camera angle, but a video of the robot moving, showing how objects shift as the arm moves, that reveals the entire geometry. The model reads those clips, reconstructs the camera to robot mapping, and suddenly it knows exactly where it is. Now, the clever part. You cannot just do this at test time and hope. You have to train the model to use those clips. During training, every single sample gets 5 random interaction clips prepended as context, pulled from all kinds of different setups. The model is forced to learn to extract the configuration from those clips to predict the right action. Same brain, Quen 2.5 vision language, 0 new parameters. The only change is the training data format. And a 5-second wiggle when you deploy. And here's the proof that it is really reading those clips. Feed the model context clips from a camera angle rotated 180 degrees, deliberately wrong. Performance drops below the no context baseline. Wrong information actively misleads it. The gains from correct context and the losses from false context are almost perfectly symmetric. That is a clean demonstration that the model is genuinely extracting the setup, not just benefiting from a longer sequence. And get this, the wiggle strategy barely matters. Random movements, XY only, rotation only. They all work about the same. You do not need a clever dance. Just wiggle and go. The numbers back it up, plus 13% on unseen camera viewpoints in simulation. On long horizon tasks, the ones where small errors snowball into total failure, it beats the baseline by over 26%. Real robot, a UR5E arm, massive gains. And the whole thing costs you 5 seconds of random wiggling and 1 extra forward pass. No fine-tuning, no demonstrations, no new parameters, just move a little, then nail the task. And the deep lesson is this. The model was never missing capability. It was missing context. We were trying to bake the entire world, every camera, every mount, every robot, into a fixed set of weights. That is a losing game. Instead, give the model a way to figure out its own situation on the fly. A few seconds of wiggling tells it everything the weights never could. The future of generalist robots is not a bigger brain that memorized every setup. It is a brain that knows how to learn its own setup in 5 seconds. Stop memorizing every camera, just wiggle and learn. That is, in context world modeling. Subscribe, because the next paper learns even faster.